Hello everyone, I'm very quickly going to go through some of the questions that you wanted me to explain. So, your marks were pretty good in these past paper questions, but in the recent ones I said, look, if there are any questions you wanted me to go over, to send me a note. So a couple of people said this question here. So the graph shows the activity of two different enzymes over a range of temperatures, and you are asked to describe two differences between the activity of the two enzymes above 20 degrees Celsius. So 20 degrees Celsius is there. So we're looking for the trend. If we look at enzyme A, okay, you can see that the line goes like that, but we need to talk about the enzyme activity and what happens to it as temperature is increased. So if we look at A, the rate of enzyme activity of A decreases as the temperature increases. However, from 20 to 35, the rate of enzyme B actually increases and then decreases. So that's one difference. A decreases as it gets hotter, whereas B increases and then decreases as it gets hotter. Any other difference between the activity? Well, if we look at the rate of activity, A, whoops, that line wasn't drawn too well. A has a much higher rate of activity than B. Now, I would need a ruler and you need to draw it more accurately, but you could say that the maximum rate of activity of enzyme A is faster or bigger than the maximum rate of enzyme B. So there you've got two differences between the activities of those two enzymes. Now, let's look at page 12, see part 3. So over here, see part 3. Now, the bit of information before that, basically an experiment was done by putting some blended food, and it told us a few pages earlier that it was 0.5 grams of food was put into a number of test tubes, different pH solutions were added, and an enzyme was added, and then the time taken to digest the blended food was recorded. So it tells us in part 3, the rate at which the enzyme digested the blended food, the 0.5 grams, at pH 2 is 0.2 grams per minute. And you're asked to calculate the rate of digestion at pH 1. Now, this graph is a little bit unusual because normally we start off graphs at 0, but in this case, pH 1 is here. And we can see that it took 40 minutes at pH 1 for the 0.5 grams of food to be digested. Now, from the information at the top of the page, it tells you they've worked out, they've calculated the rate of digestion in terms of grams per minute. So you know that you started off with 0.5 grams and it took 40 minutes. So you want to work out how many grams would have been digested each minute. So the calculation is 0.5 divided by 40. So if you put that into your calculator, you get 0.0125, and they've already got the units there, grams per minute. So simply taking the number of grams and dividing it by the number of minutes. Okay, so hopefully that's the calculation explained. And then the last question, one person wanted me to go over question on page 21, question 2. I didn't actually ask you to do it. Okay, it's in your booklet because, as I said, your booklet is for double award, but also triple award people. And I said I would tell you to leave out some pages because it's not on your specification, so you don't need to worry about page 21. The last one was on page 25. To put it into context, we need to look at the page before. So if we look at the page before, it tells us that we're looking at an investigation into an enzyme action on a cube of gelatin. So the gelatin is our substrate. And it tells us later on that gelatin is broken down by the enzyme into amino acids. So what do you know that is made up of amino acids? Well, protein. So you know that gelatin is a protein. It's actually the protein that makes jelly. Okay. And so then you can also work out that the enzyme must be protease. Protease is the name that we give any enzyme that breaks down protein into amino acids. So that gives us these answers here. Part 1, type of substance gelatin is. It's a protein, and the enzyme protease. 2 variables that need to be controlled in this experiment. Well, let's look at the experiment. They got a tube of gelatin and they added enzyme to it, and then they did it at 7 different temperatures. So the thing that is different each time is the temperature, but everything else must be the same. So things like the volume of the gelatin cube must be the same, the concentration of the enzyme solution, the volume of the enzyme solution, that all must be the same. Okay, so any 2 of those would have been fine. Then for part B, it says the investigation was repeated using another enzyme, amylase, at 35 degrees Celsius. So let's look at 35. 35 degrees Celsius gives us the highest amount of amino acid, so it's the optimum temperature. So we're using the optimum temperature, so temperature isn't going to be an issue in this case. But what are we reacting? We're reacting amylase with gelatin. Now, what do you know about amylase? You know that it normally breaks down starch into glucose or sugars. Whereas gelatin, you know, is a protein. So it says, use your knowledge of enzymes and their structure to describe and explain the results you would expect after 3 hours. Well, what are you going to expect? Will the amylase have any effect on the protein? No. Why not? Because the amylase only reacts with starch. Now, what about the structure of the enzymes? Well, you need to mention the active site. So if we think back to enzyme molecules, if that was our enzyme in the experiment, which is a protease, and if this was the protein, gelatin. Okay, if I'd drawn it properly, those 2 molecules, well, the gelatin is complementary in shape, so it fits in to the active site of the protease. What do you know about each different type of enzyme? You know that they have a different shape of active site. So if that represented amylase, which is what we're using in this second experiment, you're not going to get any result. You're not going to get any change. The gelatin isn't going to react because the gelatin is the wrong shape to fit into amylase's active site. So what were they looking for in the mark scheme? Basically what we said. So you're not going to get a breakdown of the gelatin. And we've said amylase isn't specific for protein, or we've said amylase breaks down starch. We've said that protease is the only enzyme that breaks down gelatin. And we talked about the shape. We did mention as well that the temperature wasn't the actual cause because it's the optimum temperature. Maybe we mightn't have got round to writing it down, but we'll see later on that last point isn't essential. But they're just saying if you said that, you would have got credit for it. Lock and key model. Well, we sort of explained that, but I suppose we could have mention the term, but we did explain it, so we would get a mark for that. And going back up to the top here, I suppose it's obvious. Gelatin doesn't get broken down, so therefore there's no amino acids produced. Now, when we were talking about it, we didn't mention that straight away, and we didn't mention the temperature. How many points would we have made there? So we've made 1, 2, 3, 4, 5. So what happens when the examiner's marking this in your exam? They will have a list of points, and they'll give you a tick for each point that you make fully. And then they'll count them up. So in this case, we had talked about 5. So which band are we in? Well, candidates use appropriate terms throughout. So we talked about active site, and we've talked about substrates and things like that. And explain in a logical manner what happens to the gelatin, giving at least 5 points. So we definitely got 5 points there. And if you'd used good spelling, punctuation and grammar, you would have got 6. If you got at least 5 points there, but your spelling, you had a lot of spelling mistakes, or you didn't use punctuation, or your grammar was poor, you're only going to get 5 out of 6. If you got 3 or 4 points, well, it depends on your spelling, punctuation and grammar. You're either going to get 3 or 4 marks. If you only had 1 or 2 points, you're only going to get 1 or 2. And again, it'll depend on your spelling, punctuation and grammar. And if you didn't make any points, you're going to get 0. But you can see that it is possible to get 6 points for getting at least 5 points there and having good punctuation and grammar. Okay, hopefully that helped. If there's still a few queries, drop me a private message or send me an email. Bye.